All right, applying domain and range, page 28 in your notebook. Nice. Why is it not? Applying domain and range is probably going to be the hardest out of all of the finding domain and range, just because you do have to pay very close attention to the context of the situation. You have to think about what type of numbers are being described. Okay. So, as you apply domain and range to real world situations, consider asking yourself the following questions to guide your thinking and determine reasonableness for your solutions. What are the highest and lowest values that make sense? Okay. What are the highest and lowest values that make sense in this context? What types of numbers make sense? Okay. Should the values be written as discrete or continuous, or as a continuous interval? Okay. Whew. So, first one, Remy is shopping for pears at a farmer's market. Okay, the total price of her purchase, P of X, can be represented by the function P of X is equal to 2.5X, where X is the number of pears she purchases. Remy wants to purchase at least 2 pears, but no more than 6. Describe the types of numbers that should make up the domain. Okay, well, if you're purchasing pears, think about it. What can you purchase part of a pear? No, they won't let you just go up to the store, cut off half of a pear. Hey, I'm gonna purchase half of a pear. No, whole numbers are the only thing that makes sense in this context. Whole numbers that are greater than or equal to 2, but still less than or equal to 6. She wants 2, but no more than 6. So she wants 6, 5, 4, 3, 2, 1. No, 6, 5, 4, 3, 2. All right. Now, which best represents the domain? Because we have a certain amount of whole numbers that of pairs that we would purchase, we would go with the list. Okay, we would go with discrete. The domain is a discrete set since it only contains whole numbers. For example, Remy cannot buy half a pear. Okay. When we use intervals, that's more for decimal numbers. What is a decimal number when you're looking for half? Half is a type of decimal, right? Describe how to find the values that make up the range. You're going to, okay, so how would we find those numbers? They gave us an equation here. So if we want to purchase 2 pears, we would plug in a 2. If we wanted to purchase 6, we would plug in a 6. But plugging that number in, what are we actually doing with the equation? We are multiplying times 2.5. So you're going to multiply each value in the domain by 2.5. In other words, x times 2.5. X can be 2, 3, 4, 5, 6. They actually want us to find the range. Well, let's do it then. So if we were to purchase 2 pears, if we were to purchase 2 pears, 2 times 2.5, 5. If we were to purchase 3 pears, 3 times 2.5, 7.5. If we were to purchase 4 pears, go back, second quit. All right. That would mean it would cost us $10. If we were to purchase 5 pears, it would cost us $12.50. If we were to purchase 6 pears, it would cost us another $2.50, which is $15. A set amount of costs. Our costs are either going to be 5, 7.5, 10, 12.50, nothing in between. If it was possible to get something in between, then we would write it with an inequality or as an interval. Number 2, Ben. Ben is purchasing frozen yogurt. The total cost of his yogurt can be represented with this equation right here. where X is the total ounces. Ben will purchase a minimum of 10 ounces, but a maximum of 14 ounces of his frozen yogurt. Describe the types of numbers that should make up the domain. Well, think about this. We're talking about ounces. A lot of you guys like to go to like the meat market and get pounds of meat. Do they always give you the exact, like say you ask for 2 pounds of meat, do they give you exactly two? Or when you go to the back of the deli, you're asking, okay, I want 1 pound of ham. Do they give you exactly one? No, sometimes they're off by a little bit. Sometimes they give you 0.2, 1.3, 1.4, right? Those are decimal values. It's the same concept here with this ice cream. All real numbers greater than or equal to 10. We want more than 10 ounces, but less than or equal to 14. Okay, but less than or equal to 14. Which one would best represent the domain this time? Because we can have a decimal amount of ounces, we would go with the inequality. We would go with the interval, right? And that is because the domain is a continuous interval because the number of ounces do not have to be whole numbers. Okay, describe how to find the values that make up the range. Well, for this one, what we're going to do is we're going to substitute, meaning plug in, just the lowest and the highest. Highest values of the domain. We're only going to plug in the 10 and the 14 because we want to know what's the least amount that we're going to pay, and we want to know what's the highest amount that we're going to pay. So when we do that, once again, we write it as an interval. Equal to is going to be part of that. If we plug in a 10, it would be 0.15 times 10 plus 1.5. And that would give us 3. So the lowest amount that I'm going to pay is $3. If we plug in the highest, 0.15 times 14 this time, plus 1.5. It would be $3.60. So the least amount that I'm going to pay for whatever amount of ounces I want is going to be $3, but the highest amount that I'll end up paying is $3.60. Okay. And it can be anywhere in between. You don't want to sit there and try to figure out, okay, well, if it's 11 ounces, I'm going to pay this. If it's 12 ounces, I'm going to pay this. If it's 13 ounces, I'm going to pay. That would take up way too much time. So that is another reason why we use these inequalities. I don't know why I write y equals, but I did. I'm just going to get rid of that. What we did to get that 360 is we took 0.15, we multiplied it by 14, and we added 1.5. Okay, flip it over. I need a moment. All right, so Andrea is a pet sitter and charges customers a fixed fee plus an hourly rate. The total cost per day, Y, can be represented by that equation where X is the number of hours. Andrea works between 1 to 6 hours a day. Okay. Well, let's think about what okay. Yeah, let's think about the context of it. Domain is your X values, range is your Y values. What is the domain? Domain is X. X is the number of hours. And Y, what do you get when you figure out how many hours she's going to work? The cost. Okay? Here's the thing. Is she only going to work a certain amount of hours? If you go to a job and you clock in, do you clock in on the dot every single time and clock out on the dot? No, sometimes you're off by 1 or 2 minutes. Hopefully, hopefully, you're not running late to work, but sometimes you're off by a couple of minutes, or you can even be off by seconds, right? So, for this situation, even though our domain, we're only working from 1 to 6 hours, we are, it's going to be an interval, it's going to be continuous. Um, since decimal values are an option, we're going to write it with our inequalities. So for the domain, we're going to work between 1 to 6 hours. For the range, what do? We plug in the minimum, we plug in the maximum. If we plug in the minimum, if we plug in, what's the minimum? 1 hour. Clear that out. 10.5 plus, go back, 7.5 times 1. If she works exactly 1 hour, she's going to get $18. But if she works more than that, I'm just going to copy paste on this one. If she works the 6 hours, she's going to earn $55.50. So she can make anywhere between 18 to 55 and 50 cents, depending on when she decides to clock in, clock out. Sai is ordering soap online. The total cost can be found using that equation where X is the number of soap, number of bars, and the range obviously is going to be the cost. Okay. Sai will order a minimum of 5 bars, maximum of 8. Okay. Now, here's the question. Do you think Sai is going to be able to order 5.5 bars? Most likely not. I don't think that would be one of the options. So that means that this one is going to be a discrete. He can order 5 bars, he can order 6 bars, he can order 7 bars, or he can order his 8 bars of soap. Now the range is going to be determined by plugging in each and every one of these numbers. Okay, so if he orders exactly 5 bars, let's do it that way, clear this out. My equation is 2.75 times 5, that's my X, plus 3. If he orders exactly 5 bars, the least amount that he's going to pay is 16.75. Let's say he decides he wants to order 6. I'm going to copy paste, save some time here. Then he's going to want to order, he can order 7, or he can order 8. So he's going to pay anywhere from $16.75 all the way to $25, depending on what quantity bars of soap he orders. Okay. you have to think about the context of the situation. Number 5, Maria spent 25 minutes last night reading her book. The graph shows the remaining percentage of her book as a linear function of x, number of minutes. Okay, well, none of these points are disconnected. That means this is a continuous. So the only thing we have to do is label your endpoints 0, 60 and 25, 0. They are both closed circles. So we can go ahead and safely underline everything, right? Smallest x is 0, largest x is 25. Smallest y is 0, largest y is 60. There's your domain and range. There was a domain and range question on the STAR test a few years ago. I want to say about 3 or 4. That was exactly or very, very similar to one like this. Jack launched a toy rocket from a picnic table 6 feet above the ground. Graph shows the height of the rocket as a function of x, the distance, and the distance of the rocket from the table. Okay. The height is y, the distance is x. Okay. So for our domain, notice they've already labeled the points for you. They've made it that much easier for you. And they are all closed circles. So I'm going to go ahead and underline. The lowest x is 0, highest x is 8. Lowest y is 0, highest y is 12. For 7 and 8, use a graphing calculator to help you create a rough sketch of each function, then find the domain and range. Well, let's do that then. 3 minus 5x. Let's look at the graph. Looks like that. Now, I think we've had enough practice with domain and range to know because they're both arrows and there is no third endpoint. They're both going to be all real numbers. Let's look at 8. X is equal to, or y is equal to 10, sorry. Notice you just have a straight horizontal line at the number 10. Okay, so your domain is all real numbers because we're going from negative infinity to positive infinity. But your y value stays at the number 10 every single time. So y will always be equal to 10. Okay, so go ahead and get your practice done and see you in the next video.